Now that we know the basic way of working with lists of data in C#, arrays, let's learn more about collections. In my opinion, you'll use these most of the time in your C# applications. So we've now seen arrays, and we've seen that they can contain lists of pretty much all types of data, like teachers or employees. But I hope that you agree that they do have their limitations. The biggest limitation is that we need to specify the size upon creation. They're not flexible, and when we need more space, we basically need to copy everything over manually. Also, the way to access elements and add new elements is somewhat limited. While these shortcomings aren't there anymore when we can use collections, they will often prove to be a better solution. Collections are again a .NET feature. They are classes built into .NET. The list is the most commonly used one, and that's the one we will use here too. Here's a first instance of the list class, so one of the built-in collection classes. For a large part, this looks familiar already. We have the list class, and using the constructor, we are creating a new one. But hey, there's something special going on here. Behind list, we now see two angle brackets, and in between, there's a type, int. Now what's that all about then? And I'm glad you noticed. The collection classes, and thus also the list, are what is known as generic classes. The in-between angle brackets is a type parameter, which boils down to the fact that we are specifying that we are going to create a list of integer values. Indeed, upon creation of the list, we are going to say it can contain integers. Only integers, in fact. If we would try to add something else, say an employee, we'll get a compile time error. Generic classes help us with type safety. Upon compile time, the C# compiler will check what we are adding. That means that also when we are reading out values from the list, we know for sure it will be an integer value that we're getting back in this case. One other important thing to note here, I haven't specified any size. Indeed, the list will size dynamically. When we add items, the list will have all functionality built in to ensure it can grow. So, not our problem anymore. Once our list is defined, we can use the built-in methods on the list class to add or remove items. Here I'm doing exactly that. I'm adding a few integer employee IDs by using the add method, and I can also remove an item again using the remove method. Now, although we don't need to worry about the size of our collection of items, we can ask how many items there are currently in the list. For that, there's a count property, which is built in. I do want to emphasize once again the type safety aspect here. With lists, and in fact with other generic collection classes we're getting, we'll be notified about any errors we're making against the type safety. Here you see again our list of employee IDs, which is defined with the integer type parameter, so the one between the angle brackets. Because this int is there, the compiler will ensure that we're getting compile time errors if we try to add, for example, say an employee. As said, when we later read out the items from the list, we can be sure that the value we're getting back is in fact an integer.